Very cool. It looks like the flow of attendees has sort of dropped off. So we're going to kick off. While I start, I'm going to launch a little poll that will ask about your familiarity with Hex. And this will just sort of help me tailor the session. If we have a bunch of regular users that want to learn new stuff, then I'll show you some cool new tricks. If we have a lot of novices or new people, then I'll sort of dial it down to that level. So help me make this perfect for you guys today by filling out this quick poll. Cool. It looks like we have a couple regular users, but mostly some novices or newbies. So I'll definitely make sure to give a baseline level set overview of what Hex is, and not get too complex, but I'm definitely going to show you some cool new tricks. Sweet. So today's How to Hex is about interactive reports. I'm Izzy. I'm a developer advocate here at Hex. And today, if you haven't been to a How to Hex before, I'm going to take about 15 minutes and walk you through some really cool examples of how to build interactive reports in Hex, how to make your reports interactive to end users. And then we'll have 15 minutes for Q&A, improvised demos. You can ask me questions about things that came up in the session, about other Hex stuff, anything that comes to mind. So, and I'm going to end this poll because every single one of you answered. Thank you. So we're going to do three things today. I'm going to show you some examples of the built-in interactivity in Hex, like just built-in filtering, drilling, etc. Then I'm going to show you some examples of the kinds of really complex things you can build in Hex. And then we're going to pop the hood open and actually dive into and explain that more complex interactivity and dynamic code. Sound good? Sweet. Okay. Thus ends the slide portion of this presentation. The rest is going to be completely demos. So because we had some newbies, I am going to really quickly do an overview of Hex, what Hex is. If you've never seen Hex before, it's a notebook-based tool for doing data analysis and data science. And what that means is that you break your logic, whether it's SQL or Python or no code, up into individual cells. So this is a Hex workspace or Hex project. This is a SQL cell. So this is sort of a small atomic unit of SQL code running against our Snowflake database and returning some information about dumpling orders. The really cool thing about Hex and kind of like the Hexy way of doing data analysis is that you chain these cells together to construct complex logic and answer your questions. So here we're running one SQL query against dumpling orders. Then in a new SQL cell, so broken up into another piece of logic, we're running another SQL query to sort of roll up and aggregate that dumpling orders information, visualizing it in a chart. We can pass the information from that new SQL query into a Python operation to calculate a rolling average, and so on and so forth. It gives you this way to sort of build analyses iteratively in a way that's really easy to observe and introspect, and is kind of self-documenting. And what we're going to be talking about today is the fact that once you are done with an analysis in your notebook, Hex lets you take that logic from your notebook and really easily drag and drop and turn it into an app or a dashboard or a report that you can actually surface to end users and give to people as a way to interact with the information or the insights without having to download and run a Jupyter notebook or use a sort of static slide deck, etc. Today, we're going to specifically be talking about interactivity. I'm going to show you a couple examples of this. First, we're going to talk about just the built-in interactivity that you get just by virtue of building a report in Hex without having to do any kind of configuration. So, and some of this is really new stuff. So if you've only been using Hex for a little bit, or if you've been using it for a while, this might be new to you. So this is an example of a fairly complex Hex app. It has a bunch of different tabs. It's like a customer 360 dashboard that lets us dive into a specific customer's usage metrics. And this is actually our internal customer 360 dashboard, but obviously with not our internal data. And here, I'm not going to talk about this just yet. I'm going to talk about our built-in cross-filtering, drilling, and exploration. So when you build a project in Hex, build an app, a dashboard, anything like this, it automatically comes with a bunch of built-in interactivity for end users. So I'm viewing this as an end user. I don't know how to write SQL. I don't know how to write Python. I'm looking at this app and I'm like, huh, this is kind of a weird little drop off right here. I wonder what happened in March. I want to sort of zoom in on that. I can just scrub over that, and Hex native chart cells support this interactive filtering. And more than that, they support interactive cross filtering. And so these two charts are different data sets, different data frames, but they share similar columns and axes. And Hex is clever enough to, without any configuration done by the editor, say, oh, it looks like there's another data frame in this project that looks really similar to this one. Do you want to apply the filter to that one as well? And I'll say yes. And now both of these charts are going to be filtered down to just that time period of interest. And we can see that it got added to our filter bar up here. And once it finishes running, which might be really slow because this is running against the staging version of our servers. There we go. And so once this finishes running, the whole app will be cross-filtered without an editor having to do any kind of pre-configuration, without me having to know anything about the underlying data and how it maps together. It all happened pretty much automatically. And another thing that's interesting about this app is that if we go down here, this data set or this table is also automatically filtered down to map to this chart. So maybe let's zoom in more on this chart. And let's not apply it to the other elements. We'll just apply it to this chart. We can see that this table automatically updates as well, because this chart is actually being used as a visual filter applied to this table. And I'll show you how this works on the back end in a moment. But the point really is that there's sort of these multiple tiers of filtering logic that you can apply. You can apply a chart level filter, which you can also configure without having to do the scrub manually. You can apply cross filters that apply to every matching element in a project. And you can also configure specific elements to act as filters for other elements. So right here, we've set up this chart to act as a filter for this table display. You also have your typical sort of dashboard level filters. So here, as an editor on the back end, before I built this chart or before I published this app, I set up a filter on customer segment. Now, an end user of this app can choose what customer segment we want to look at, and this will apply globally to every single data frame in the project that matches this customer segment field. So we can see it's applied to 2 cells right now that have that, and all of these have updated appropriately. So you have kind of these 3 different levels of built-in filtering. You have global dashboard level filters, which we call shared filters because they apply to multiple elements. You have individual cell level filters, which can also be automatically applied as cross filters to matching elements. And then you have directly mapped sort of like downstream filters from charts, which can be used to visually filter down table display cells. And between these 3, you can build some pretty complex workflows. You're not limited to just the sort of global level dashboard filter like in a traditional BI tool, where you apply a filter and every single tile updates. You can specifically exclude some tiles from this filter. You can filter other things individually. It gives you a lot more flexibility. Just really quickly on the back end, we'll look at how you configure that shared filter. And this is a super new feature. It's in beta right now, so it might not be on for all of you yet, but it will be coming soon. These are really easy to configure, which I think is actually one of the cooler things about them. On the back end, I'm going to just select this element, and I'll also select this element. And it says, do you want to add a new filter? And just like how when the user cross-filtered in the app, I didn't have to configure anything, it's almost that simple on the back end too. I just choose which columns I want to filter, and it has automatically found all of the matching columns between these 2 charts. I'll say customer segment, and I could pre-add some options here, but I can also leave it blank for the user to fill in like I did previously, and then we're done. And that's all you have to do to configure a filter across multiple elements in an app. Okay, there's one more thing that I want to show that's part of the built-in interactivity of Hex apps. Let's go back to the published version of this app. This doesn't have to do with filtering. This has to do with exploring. So I already showed you how you can filter down this data super easily, but what if you want to drill into the aggregate or the unaggregated data behind this chart, or actually like visualize something completely different? In a traditional case, maybe the end user would have to ask the data team to go back and rebuild it or to tweak it or add a new filter or something. In Hex, you can view the data behind any chart or table. And so here you'll see if we click out, this is sort of an aggregated sum of the MRR of every single customer on every date. And if we drill in, we can see each row broken out with all the information that goes into each row. So we get this like drilled, aggregated or unaggregated view of all the data. It can be downloaded. You can also explore. This lets end users kind of remix and rebuild visualizations, answer their own questions, create their own little mini Hex project basically off of any chart or table in a published app. And again, this all happens automatically in Hex apps if you're using native Hex chart cells. So you didn't have to configure anything or sort of like set up the app for exploration. All you have to do is publish an app that uses Hex chart cells, and customers will have, or end users will have this interface so they can browse the tabular data. They can add filters. So maybe we'll filter this down again to only a specific customer segment. I don't know why that's not working. We'll say it's only single tenant users. You can add new elements to the chart. So let's also look at the number of paid author seats over time, maybe as a line. You can create pretty much like anything you want from this Explore interface. And if you really want to take it to the next level, you can open an Explore in a new Hex project. And if you're like a technical developer, then you get all of the values or all of the cells necessary to construct that final element in a project, and you can keep developing from there. So that's pretty much the extent of the built-in interactivity that you just get out of the box by virtue of building apps in Hex. Let's now look at some of the extra interactivity that you can add on top of that using input parameters. Oh, and there's also, I forgot one more thing. There's something called a filter cell. So here we're in a published app, a totally different app that's a dumpling sales forecast. And we have sort of in the middle of this app, so it's not a global level filter, we have this filter cell. And this lets users configure really detailed specific filters inside of the app that apply to specific elements. So sort of like how we saw that chart and we scrubbed a filter onto it and it applied to a specific downstream element. Here, we're using this filter cell to filter down a data frame that's then being used to build this forecast downstream. So the user can change the category of food that's being forecasted. We'll change it to veggies. And they could say it's spicy, or even add the completely new filters. And as an editor, you can choose whether you want to let a user add entirely new filters or change what the filter criteria are, or if you want to just let them change the values that are being filtered on. And we saw that this all updated. So that's another sort of like built-in piece of interactivity. The last thing that lets you build really complex interactivity into your app are input parameters. This is a really simple example of an input parameter, but I'm going to show you a more complicated one in a moment. So this lets you tweak a dropdown and affect downstream Python or SQL code. So we can see that this forecast shortened when we drop this value down. So we'll change it to 12. This will rerun and reforecast with a 12-month forecast. The way that this works, let's pop into the backend. It's actually sort of deceptively simple, but you can use it to construct a ton of complexity. So in the backend of this app, in the notebook, we've added an input parameter. And there's a ton of input parameters. We have buttons, checkboxes, dates, dropdowns, multi-selects, numbers, sliders, tables, text. This is a number input. You can change the increment size on it. And all it does is return a value or variable with that number. You can print this out in Python. We'll just say months to forecast 40. And you can use this downstream to parameterize your code. So here, we're constructing a data frame with our future dates to make our forecast against. And instead of setting a sort of static period like this, we're saying period is months to forecast. And that means whenever we change this input parameter, Hex reruns all of the downstream cells of this input parameter, which it's able to figure out by leveraging the graph-based compute model that Hex uses. So we can see we have our input parameter here. Downstream of it is this future date construction Python cell, which actually does the forecast as well. And then this visualization step. And so it knows it doesn't need to rerun any of this stuff. All it needs to do is run these two downstream cells. This is a really, really simple example, but this works at like an incredibly complex level as well. Here's an example of a super complex app that includes input parameters throughout the entire app to make a like long form white paper style report interactive. And I'm going to walk through the app of this and then we'll pop into the backend, but I'm going to point out some parts of it that are made interactive via clever use of input parameters. So here, sort of halfway through the app, there's no global filter or anything. It reads like sort of a interesting doc style report. But all of a sudden, we have an interactive component here where I can change which customer I want to visualize in this specific chart. And this doesn't impact anything in this entire report except for these two elements. So you can create these little islands of interactivity that don't impact the rest of the report. And if I keep scrolling down, it's sort of, I'm still learning about the overall forecasting model for our pricing here, but I've been able to like explore into this little specific piece of interactivity in this one little section. And you notice that was actually pretty fast. Again, that's because of that reactive graph-based execution model. If we look up, there's like, oh my gosh, a gazillion cells in here, but it didn't have to rerun all of these cells. It only had to rerun these two cells. Just a little point of cleverness that makes interactivity, even backed by complex notebooks, feel really fast and sort of like BI speed. And again, down here at the very end of this report, we have another little pocket of interactivity where we can simulate some changes to the model configuration. So let's change our potential algorithm for pricing. And we can see that these few charts automatically update, and we can see our new modeled profit without affecting the actual overall message, which is that the trailing four model is the winner. So we can change this to look at just the baseline, but we haven't altered the context that's being added to the project. On the back end, what this looks like is really similar to what I showed you before. Let's find one of these input parameters. Here we have that customers of interest input parameter. We can see it's being referenced in code 39, which is this complicated chart cell. We've built a chart config here using JSON. And then here we have a little if statement that basically just takes in that customers of interest item. And you can add multiple there because it's a list, filters down the data set to display, and then builds a chart that displays that filtered down data set. This gives you like really, really, really fine-grained control over the kind of interactivity that you build. You're not just like mapping cells to one another. You're literally getting variables that you can use in Python conditional logic, pass into other code, and using SQL. So here we have our cost modeling set up, and we're basically calculating a bunch of average data. You can use this to parameterize SQL queries as well. So here in this SQL query, we're parameterizing with the average price using this little double bracket syntax. And so we could just say divided by like 2 or something. But if we want to make this dynamic to user input, we can, here, we'll do this now. Oops, need to rewrite everything. We'll add a new dropdown or a number input. We'll say price metric. We can make this, I don't know, 10 or something. And then we can take this price metric value and use it to parameterize this SQL query. And just doing this double bracket Jinja syntax, passing in the variable and rerunning the query. What did I do wrong here? Oh, I think it just hasn't rerun yet. Lets us dynamically change the SQL query or any SQL query downstream of user input. So we change this to 40, the cell will automatically re-execute, and we can see our price coefficient has updated. You can use this to pass in lists. So we could turn this into a list parameter or a dropdown with a bunch of different options, 40 and 50. This obviously won't work because this is a little bit wonky, but then we could say array, and we could actually pipe in an array of values into the SQL query, and this won't run. But if we look at the compiled SQL, we can see that, oh, I guess I didn't, it's a dropdown. That was a bad example. But you can pass in lists, treat them as arrays, and construct really, really complicated SQL-based logic that's parameterized as well. A great example of this, I think, is the feature success dashboard that we actually use internally, which gives you a bunch of different dropdowns. Let's look at the published app. Gives you a ton of inputs of which feature you'd like to look at, like how many times have users used the crop tool, the brush tool, what subscription tier are they on, what role are these users, and then on the back end, it's using these. It's using these in SQL cells and Python cells to parameterize the downstream logic. So if we take a look at these SQL cells, keep scrolling. In this where clause here, we're joining a bunch of different tables together and then adding filters on launch date, on the different user roles, the subscription tiers, and building this complex parameterized logic using input parameters. Cool. That rambled a little longer than I was expecting it to, because there's a lot of different moving parts here, but I hope that gave you a good overview of built-in interactivity across global dashboard style filters, specific cell level filters, and app cross filtering, as well as the kinds of really, really complicated like islands of interactivity you can create in reports using input parameters. I know there was a lot there, so I'm happy to answer questions and drill into any specific thing that I kind of blazed through that you're interested in learning more about. Oh, and one more thing that I forgot. You can parameterize Markdown and text also. So in this Price of Spice app, near the top, we have a text cell here where we're adding some context about how much of our revenue is for spice production and sale. And you can see these blue highlighted sections are parameterized to be dynamic from this spice purchases data frame up here. So you can build apps, and if you sort of construct your grammar in the right way and use this Jinja parameterization, you can build apps with written context that are never outdated. So you could imagine spending some more time and parameterizing this 3-month section, this percentage. You can build apps this way that don't go stale. I think a big pain point of a lot of people when they start building hex apps is that they build some super complex app and add a bunch of logic and context to it. And then they come back a month later and it's like, oh, all these numbers that I wrote down are out of date. But if you use this dynamic text parameterization, you can see I'm doing a little bit of like Jinja logic to round this and actually calculate a sum right here. You can build apps that are kind of evergreen and never go out of date because they're dynamic directly from the live data source. Cool. Okay, that's actually it. I'll look at the chat and the Q&A now, but yeah, we've got 5 minutes. We can run a little longer if you want to answer any questions that you might have. Okay, I'm looking at the chat, but please add more questions as I go. Is an editor license needed for built-in filtering? That's a great question. Editor or can view access, I think, is required for view data, and editor access is required for exploring. Viewers can filter and viewers can view data, I believe, but you must have an editor license in order to explore. Leon says it's easy to let business users do their own explorers, but prevent them from accidentally mangling published dashboards. Yes, I think so. I think maybe what you're getting at here is like, are they going to mess it up for everyone else? And the answer is that when you are in a Hex app, you're in your own app session here. So if I change the filtering here, and then somebody else fires up this Hex app, they won't see the changes that I've made. They'll see sort of the base published version. And you can see that again, like if I refresh this app and reload it, it will go back to the base version. So you don't mess it up for other people. If you want to share a session, you can grab, sorry, the Zoom thing keeps getting in my way. You can grab a link to a live session where people will be able to be in the same session as you and see the inputs update live, but that's not the default state. So you don't mess things up by default. Someone says, can you give us access to the what's the price of spice stock? Yeah, everyone has access to this. If you go to the use cases page on Hex and go to, I believe, exploratory analysis and go to interactive data stories is what we've called it, you can access the price of spice app here, both the published app and the logic. But you know what? I'll just paste it into the chat as well. What is next? Can we add custom Jinja macros across the project account? You can in your project, but not across the whole account. It's actually an interesting concept to be able to add like workspace-wide Jinja macros. Not a bad idea. But yeah, you can do it in your project. Someone says, is there a way to suppress warnings in the app? With missing input data, a chart may not run, so an error would show up in the app. Yeah, Robert, this is a good question. So basically, like if you want to configure a zero state almost for an app that doesn't have data because the user hasn't provided an input yet, the way to do this, I think, would be with some conditional logic. So probably like if statements, which you can do in SQL cells. Actually, with Jinja, you can build sort of complex if statements. So if input is null, then select one, otherwise run this whole SQL query. And I would basically create like a dummy data frame that has the right columns, but very little or zero data in it, so that the actual configuration of a chart doesn't break, or any downstream cells don't break, but it doesn't return any data. And then when a user makes a selection, you can update that query dynamically using Jinja to actually answer the question. I can show you what I mean, because that felt a little abstract. So basically here, I'll add Python cell and just set like run equals true. And then in this SQL cell, we can say if run select 10, else select null, and we'll call this like value. And so this way, run doesn't exist yet. I need to add an end. So here, I don't know why this is taking so long to run. Oh, I think probably because I put single quotes there, but it runs fine in DuckDB. So this way, no matter what the value of run is, you're going to get a column that says value here. If we change this to false and we run this, we'll get null, but you still have a data frame that you can pass into a chart without breaking the configuration. So you can build this kind of complex logic in SQL. Sorry, that was a long answer to your question. Jonathan says, how can you version control these notebooks? We have built-in versioning. Let me find a more complex project that gives you a view of all the edits that are made, as well as the ability to actually see and revert to previous versions of the app. So I could pop this open and revert to an old version. We also have a Git integration, so you can save your notebooks to Git and actually require pull requests in order to publish new production versions of the app. Okay, we'll do one more question. Looking for an exciting, interesting one. Ken asked a great question, which is, do you have any tips for ensuring computational performance of dashboards that have interactivity? Yes, and I think this actually might be the subject of a future How to Hex series, because there's a ton of little tricks you can do when you're configuring your notebook and setting up how the logic chains together and how caching works that make it faster. In an ideal world, and we're kind of striving towards making everything as fast as possible by default. But the short answer is yes, there are ways to make this faster, and we'll do a whole session on it. Okay, cool. I think we're well past time, so I'm gonna wrap it up here. If you have more questions, feel free to email them to me. I think I sent you emails inviting you to this, or tweet at us, or come find us any other way. The recording for this will be posted on YouTube, along with the recordings for the previous How to Hex session. So if you want to learn about other stuff, you know where to find it. And we'll email those to you, I think. Thanks, everyone. Bye. I don't know how to end the webinar.